Hello everyone, welcome to this new session. So today we are going to start a new topic which is not a very familiar topic for lower level mathematics. It is called nonlinear dynamics. So what is nonlinear dynamics? So there are two terms, one is nonlinear, another is dynamics. So when we say something is dynamics, related to dynamics or dynamics, you can say, though we have studied it in mathematics, but basically this is a concept from physics. So when Newton first discovered this differential equation, and from there, through differential equation, we can express some of the moving particle or some of the nature of some particle. So that will be the dynamics of that particle. So what is the meaning of dynamics? The meaning is that it is very simple, that when we try to study some property with respect to time, to someone or to something, that represent the dynamics of that particular things. Okay, so let us not go to very complicated manner. Let's create a very simple example. Say let me give, so when you try to study dynamics, or more specifically nonlinear dynamics, so you need to have some prerequisite. What are the prerequisite is needed? Number one is needed ordinary differential equation. Number two is needed the idea of linear and nonlinear system of equation. So let me write something here. Say dx dt equals to ax plus by and dy dt equals to cx plus dy. Now this is one differential equation, this is another differential equation, but combinedly these two are called system of ordinary differential equation. Now look into the right hand side. In the right hand side, so if I go for the degree and order, so the order is 1 because one time derivative is there involved, and the degree is also 1 for individual equation. Now if I go for the linearity or non-linearity, both the equations are linear because there is the power of x is 1. So what is mean non-linear? When power of x will not be 1, I mean power of the variable, or if there is something multiplied form, then it should not be linear. Okay, so this is a linear system of equation, I mean differential equation, you can say. Now if I take another one, say let me write something, a second order equation. So d2x dt2 plus g by l sin x equals to 0. Now look into this one. So now when first time you observe this one, you can say, okay, this is a second order equation. Now our idea is that for a second order equation or for any arbitrary order equation with constant coefficient, can we able to write this in a system? So I think this is not very clear. Let's try. So now you see, so if I write, say this is equation number 1. So let x1 equals to x. Okay, so that means dx1 dt equals to dx dt. Okay, and let's say x2 equals to dx1 dt. So now what will be this equation? This equation, can I write, this is ddx of dx dt equals to minus g by l sin x. Now we know x means x1, so this will be ddx of dx1 dt equals to minus g by l sin x1. Now what is dx1 dt? Dx1 dt means x2. So here we are getting this will be dt, extremely sorry. So dx2 dt equals to minus g by L sine x1. Now carefully see, we have got two relations. What is the first relation we have got? So from 1 we have got two relations. One is this one, another is this one. So we introduce two variables x1 and x2, and we have got two differential equation. One is dx1 dt equals to x2, another is dx2 dt equals to minus g by L sine x1. So basically this is kind of parametric form. So what we have done, some equation was given to us, and that equation we try to write in a system of equation form. Now look into this system of equation. The first equation, this is also first order equation and first degree equation. There is no doubt about that. Now look into the first equation in this system. The right hand side is a linear part. The second one, the right hand side is non-linear, because sine x1 means this will have one infinite series expansion, right? Like x1 minus x1 cube by 3 factorial plus x1 to the power 5 by 5 factorial, so on. So basically we have got the non-linear terms in the right hand side. So this system of equation we can derive from the equation number 1. But what is the contrary of this system along with the previous system? This system is not a linear system. So you need to understand what is ODE, that all of you must understand, those who are appearing for this course, and you need to understand what is linear and non-linear system of ODE. So probably with this example we have given you some idea of that. Now very interesting things are there in this topic. So if I concentrate this one, so you see here how many independent variables are there. So independent variable is t and dependent variable is x1 and x2. Understand? Because the numerator is usually dependent and independent, this one. Now look into this one. What we can do, we can solve this x1 and x2 from here, and we can plot. Carefully you see. But how we can plot? We can plot x1 and x2 graph. So that is, we can plot two dependent variable with respect to each other. Okay, so there is no role of t directly. So we have plotted x1 and x2 axis, and maybe there is some plot like this. Okay, so if this one is this point, so this point is say x1 t1, x2 t1. This point is say x1 t2, x2 t2, and so on. This plot or this type of graph has a special name. It is very much useful for very mathematical modeling or mathematical biosciences researches. This is called phase plane or phase portrait, and this curve is called trajectory. So we are familiar with this kind of terms, that trajectory. So trajectory, basically in this case, trajectory means it is the curve situated in the phase plane. But how you can construct phase plane? You can construct phase plane with respect to these two dependent variables. That is, you can draw a curve x1 versus x2 axis, and whatever curve you are getting, the curve is trajectory, and this diagram is called phase plane or phase portrait. Okay, so now if I go for the next one, so now if I concentrate about the system, so there are basically two kind of systems. One is called autonomous, another is called non-autonomous. So autonomous means, say, let me give one example and try to clear this with example. Say dx dt equals to ax plus by, dy dt equals to cx plus dy. And here I am giving another example. Say dx dt equals to minus x and dy dt equals to minus y plus e to the power t. Now look into these two examples first, then we can discuss what is means of autonomous and non-autonomous. You see, look into the left hand side example. There the dependent variables are x and y, and independent variable is t. But in the right hand side, no t was present, only x and y was present. So this kind of system is called autonomous. That is, the independent variable is not expressing here. On the contrary, you look into this non-autonomous system, that means the independent variable will have a separate present there. So that is this term. So non-autonomous means here t, so t must be present, and here no t. So this is the basic idea of autonomous and non-autonomous system. So basically we can deal with both the system, but basically 90% of the case we'll be dealing with probably autonomous system in future. Okay, x double dot plus 2x dot minus 8x equals to e power t. So here what we'll be doing, we try to convert this as a system of equation like the previous one. So what we'll be doing x1 equals to x. So the x you have to assign to some variable, and x2 equals to x1 dot. Now x1 dot means basically it is x dot also. Okay, so now if I concentrate on this one, this is basically d dt of x dot plus 2x dot minus 8x equals to e power t. So x dot means d dt of x2 plus 2, x dot means x2 minus 8 x1 equals to e power t. So this is actually x2 dot equals to 8 x1 minus 2 x2 plus e power t. So what we have got? We have got two equation again. So basically what we are doing, we are eliminating this x and we are converting this system into the form of x1 and x2. So we have got x1 dot equals to x2 and x2 dot equals to 8x1 minus 2x2 plus e power t. Now can we write this one in the matrix form, that is x1 dot x2 dot equals to, if I concentrate this x1 x2 matrix, so that is 0 1 8 minus 2, this is x1, this is x2 plus 0 e power t. So now basically this is of the form x dot equals to a times capital X plus b. So a system of equation we can write in this form that we know in a matrix form, but for that you have to convert this and then only you can write. Okay, so now we'll be going for the next topic, which is very important, which is called vector field. Which is called vector field. So let me give one example first. So what is the example is this? Say I am giving an equation, say dx dt equals to sin x. So if I just try to solve this, it will be dt equals to cosec x into dx. If you integrate, it should be t equals to log of minus log of what? Cosec x plus cot x plus some constant k. So basically if at t equals to 0, if x equals to x naught, so this x and this x is actually same, so I am writing in this style, so pardon me for that. So k will be log of cosec x naught plus cot x naught. So we have got, if I replace k, it should be log of cosec x naught plus cot x naught divided by cosec x plus cot x. Anyway, so we know this kind of solution. Okay, so here the condition was given, x at the point 0 equals to x naught. So if some differential equation is given to us, we can solve this and we can got some idea. But if the next question is that what will be the behavior of this solution, can you draw it? The answer is no, because every problem it is not possible to draw this kind of behavior. So how we can get the idea of behavior of the equation? In terms of solution, we may get the analytical solution, but geometrically it is next to impossible sometimes. So then we have to use some other technique which is called vector field. Okay, so let me go to the vector field. So vector field, what is the meaning of that? Vector field, so I am just erasing this part. This is the formal part. Suppose I want to draw the vector field of this one. So this equation I can write x dot equals to sin x. So vector field means it is a graph of x versus x dot. Let me draw this, because sin x we all know this, so we can just draw this. So at this point this is 0, this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi, this is minus pi by 2, sorry, minus pi by 2, this is minus pi, this is minus 3 pi by 2, this is minus 2 pi. So this one is x and this one is x dot. So don't be confused between this vector field and your face portrait, because in face portrait you need two dependent variable and the graph between two dependent variable. So face portrait is basically for a system of equation, but vector field will be for the single equation. Fine. Now something you need to observe. What is the second point in the vector field is that you have to put some arrow, or you have to put some direction. And the third point is that you have to find the fixed point. So always remember, these points will be fixed point. This point will be called fixed point. Fixed point means where x dot is 0, that is the growth is 0. So this is fixed point, or later on you can call this as equilibrium point also. Now what is the meaning of, so we can understand what is a graph, we can understand what is fixed point. Now what is the meaning of direction? Look into this one. So let me just erase this portion and discuss what is direction. So direction will be along this axis and around this point. So you see, in the left side of minus 2 pi, the curve is negative. So the direction will be less than sign. In the right side, this is also, this is. Okay, so we have got different kind of arrows around this fixed point. Now look into this one. Look into this point. If I just try to concentrate on this one, so here two arrows are going to the opposite side, and here two arrows are coming to the same side. So if it is going to the opposite side, so if arrows are like this, if it is going to the opposite side, then the point is called unstable point. Okay, and if the arrows are coming towards the same side, this is called stable point. So that means this point is unstable, this point is stable, this point is unstable, this point is stable, this point is unstable. So from this class, in the last topic, what we have learned? So we have learned that for a differential equation, you can try to draw the vector field, and when you try to draw the vector field, so there may be some fixed point, and the fixed point will have different nature. Either it will be a stable fixed point, or it may be one unstable fixed point. So for that, we have to draw the direction according to the fixed point. So if the directions are away from each other from the fixed point, then the point is called unstable. If it is towards the fixed point, it is called stable. So like that, we can draw that. So that's all for this class. Very soon we'll be going for the next video on this. So keep in touch. Thank you.